today's problem from constrained motion of particle dynamics, and the problem is a rough cycloid has its plane vertical and the line joining its cusp horizontal. A heavy particle slides down the curve from rest at a cusp and come to rest again at a point on the other side of the vertex, where the tangent is inclined at an angle 45 degree to the vertical, right? So that the coefficient of friction satisfy the equation. The equation is given by 3 mu pi plus 4 into log 1 plus mu base e. This is equal to 2 into log 2 base e. This is our problem. Here it is said that the joint its cusp is horizontal. Okay. So for the cycloid, we draw a rough sketch of cycloid in which the cusp, if we join by a straight line, this is horizontal. Okay. And it is also said that a heavy particle is slide down the curve from rest at a cusp and comes to again rest at a point on the other side of the vertex. This is the vertex. Okay, this is the vertex O. We draw a tangent at the vertex, and this is also a horizontal line. Let the cusps are A and B, right? And let at any point P the particle slides from rest from the point A, and let at any point P the coordinate of P is S psi at any time T. Any time T. Okay, time T. And we draw a tangent at P. This is the tangent we draw from the point P of the cycloid. Let it makes angle psi with positive direction of the tangent to the vertex. Okay, and here the mass, that is the weight mg, act vertically downwards, and since it is a rough cycloid with coefficient of friction mu, so there will be a frictional force mu r acting opposite side of the tangent. Okay, and this is the normal reaction, act vertically. Sorry, this is act inward normal. This is R, right? This is our general point, and these are all the forces. Now at the point A, if we draw a tangent to the cycloid, we know that here psi, this is equal to pi by 2, and intrinsic equation of the cycloid is S, this is equal to 4a sin psi, and we know that ds by d psi, sorry, this is d psi, this is equal to 4a cos psi, and this is the radius of curvature. This is denoted by rho. We use this result in our problem. Okay, now we write the equation of motion along the tangent and along the normal, and we know that the tangential acceleration always act along the positive tangent, and here the vertex O, we here measure the arc length S from O to P. Here OP, this is the arc length, this is given by S, and it is said that the particle again at rest when it inclined at an angle 45 degree to the vertical on the other side of the vertex. So at that position, if we draw a tangent where the particle becomes at rest here also V, this is equal to 0, it is given, and at the final position, and here if we draw a vertical line, then this angle is 45 degree, it is given. So this must be 45 degree because this is vertically opposite, 45 degree, and this is 45 degree, means this is also 45 degree. Okay, because this is pi by 2 right angle, and the angle makes the tangent at that point, let it be Q, with the positive direction of horizontal line at O is given by this, and this is also 180 minus 45 degree, so this is 135 degree. Okay, that is here psi, this is equal to 135 degree. This is the final condition where V equal to 0 and psi equal to 135 degree. And at the initial position, psi this is equal to pi by 2, this is 90 degree, and here also V this is equal to 0, because the particle slide down the curve from rest, it is given. Okay, now come to the point, that is come to the equation of motion. We know that the tangential acceleration or tangential force, this is m v dv ds, act along mu1, and this is the positive tangent. And we know that m v square by rho, this is the normal force or normal acceleration per mass m. Okay, act along the inward normal. Now we write the tangential and normal equation of motion as equation of motion R. The first equation of motion is tangential mv dv ds. This is equal to, we first add mu1, because mu1 is the positive force along the positive normal, and this angle, this is given by pi by 2 minus psi. So the component of mg along negative normal, this is given by mg cos pi by 2 minus psi. This is mg sin psi, and we subtract here mg sin psi. Okay, because mg sin psi is opposite to mv dv ds, right? So there are no force along the tangent. So this is the tangential equation of motion. We name this is 1. And now normal equation of motion is m v square by rho, and this is given by r minus, because this is the inward normal, this is the normal direction r, and the component of mg along opposite side of the inward normal, that is along the outward normal, is given by this is mg cos psi, because this angle is psi. Okay, so we get r minus mg cos psi, and this is named as relation number 2. Now eliminating r from 1 and 2, we get as m, and this relation can be written as m by 2 into dv square by ds, because v dv ds, this is equal to half into dv square by ds. We directly write this, and the right side is mu into the value of r from 2, we get m v square by rho plus mg cos psi minus mg sin psi, and we see that we cancel out m from both sides, we get the relation becomes, we delete m from here, right? Now here we put the value of rho. The value of rho means we first put ds by d side. Now if we put here ds by d side, then we get the relation as half into dv square by ds into ds by d side minus mu v square this is equal to mu into g, sorry, we take common g here, and this is mu into cos psi minus sin psi. Okay, and there will be another ds by d psi, and we write here ds by d psi as 4a cos psi. Okay, and we multiply 2 in both sides, then we get the relation. This is 2 here, and this is also 2 here, and this is ds by d psi means 4a cos psi. So we get the relation dv square by d psi, because ds cancel out, minus 2 mu b square, and the right side is 8 ag, because 2 into 4 8 ag into cos psi into mu cos psi minus sin psi. Okay, clearly it is seen that this is a linear differential equation of first order, and here linear in v square. So integrating factor of this differential equation is given by, we know that the rule of integrating factor to find for the first order linear differential equation, this is given by integrating factor. We write it if, this is e to the power minus p dx. Okay, and we write here e to the power minus integration. Here p is this term, that is, sorry, this is not minus, this is p dx, and here p is minus 2 mu, because this is the term mu, sorry, p. So minus 2 mu and not dx, we write here d psi. So the integrating factor is e to the power minus 2 mu psi. Now by multiplying integrating factor in both sides of this equation, we write this equation as d psi of v square e to the power minus 2 mu psi. This is equal to 8 ag into cos psi into mu cos psi minus sin psi into e to the power minus 2 mu psi. Okay, we multiply both sides by the integrating factor, and we multiply this side in right side here, and now integrating, we get the integration of this and the integration of this, and there be an integrating constant. This is, we let, this is integrating constant is c, right? So by integration we get d square e to the power minus 2 mu psi. This is equal to, right side is 8 ag. Okay, and in this type of integration we put here e to the power minus mu psi into mu cos psi minus sin psi. This is equal to z. Okay, this is a very short trick to integrate this type of large integration. Otherwise this integration may be a large type of problem. Okay, so we put this integration, and by differentiating this term we get the result as, we write here directly the substitution without any derivation. For reduce the length of the video, we write here e to the power minus mu psi into cos psi into d psi. This is equal to minus dz by 1 plus mu square. Okay, we get this result by derivating this. Now by putting the value of z, we get the result as minus z into dz by 1 plus mu square plus c, right? And this get minus 8 ag by 1 plus mu square into z square by 2. So we write here 4 plus integrating constant c, and putting the value of z, we get the result as minus 4ag by 1 plus mu square into z is this, so z square is given by e to the power minus 2 mu psi into mu cos psi minus sin psi whole square, and this is integrating constant. Okay, so we get the relation of v square. We write the value of v square. This is given by we multiply both sides by e to the power minus 2 mu psi and get the result as minus 4ag by 1 plus mu square into mu cos psi minus sin psi whole square plus c into e to the power 2 mu psi. Okay, here e to the power 2 mu psi, e to the power 2 mu psi cancel out, and here we get an e to the power 2 mu psi. Okay, this is our final result of integration. We name this relation as relation number 3. Now we put two conditions given here. We first put the initial condition. Initially it is said that at psi equal to pi by 2, v equal to 0. So from this relation or from 3 we get this is 0 and the right side is minus 4ag by 1 plus mu square, and the right side is mu cos pi by 2 means 0 minus sin pi by 2, this is 1 square plus c into e to the power, this is 2 mu into pi by 2, so it is given by mu pi, right? This is the first condition. And also we put the second condition, that is the condition at the point Q. Here psi is 135 degree, and we also put the value of psi instead of 135 degree as psi, this is equal to minus 180 degree minus 135 degree, and this is minus 45 degree, that is minus pi by 4. Okay, so we put here psi, this is equal to minus pi by 4 and v equal to 0, and get the relation from 3 as this side is also 0, left side, and the right side is minus 4ag by 1 plus mu square, and this is mu into cos minus pi by 4 means 1 by root 2, and sin minus pi by 4, this is minus 1 by root 2, so we get here minus minus plus, and c into e to the power mu minus mu by 2. Sorry, yes, this is right, psi is minus pi by 2, so minus mu by 2 here. Okay, and we can also put here 135 degree means psi, this is equal to 3 pi by 4, get the same result. Okay, now we find out the value of c from here, also from here. Okay, and here another pi by 2 is present because psi is minus pi by 4. Now first we calculate the value of the integrating constant c from the first relation, that is we get from 3. So we get here c, this is equal to 4ag by 1 plus mu square into e to the power minus mu pi. This is the first relation of c, and we put this value of c in the second relation and getting the result as this is 0, this is minus 4ag by 1 plus mu square, and this is here a square, and we get mu plus 1 whole square by 2 because LCM is root 2 plus the value of c we put here 4Ag by 1 plus mu square into e to the power minus mu pi into e to the power minus mu pi by 2. Now we cancel out the term 4Ag by 1 plus mu square, because in two terms this term is common. So we cancel out 4Ag by 1 plus mu square and getting the result as 1 plus mu whole square by 2, because this is minus. So we changing the side of this term, and the right side is e to the power minus 3 mu pi by 2. Okay. Now taking logarithm of both sides and getting the result as log 1 plus mu whole square minus log 2 base e. This is also base e, because log a by b means log a minus log b, and the right side is obviously log e to the power minus 3 pi mu by 2, and this result gives 2 into log 1 plus mu base e minus log 2 base e. This is equal to minus 3 mu pi by 2. Okay, so we again, by calculating this term, we clearly see that this result is same as the given result, and the given result or required result is given by 3 mu pi. This is equal to, this is plus 4 log 1 plus mu base e. This is equal to 2 into log 2 base e. Okay, this is the complete answer of this problem, and this is the required result we get here, right? And this is our proof. Thank you for watching.